So good afternoon, everyone. Welcome to our second class on index number. So in the first class, we discussed about what index number is all about. We discussed about the basics on index number. So in the last class, we discussed about the basics on index number, why we use this concept called index number in statistics, what is the practical relevance of this concept called index number. So normally, why we use index number, basically when we work on macroeconomics, and in macroeconomics, when we are analyzing a certain set of variables over the two time period, where we one time period is called base time period and the another time period is called current time period. So basically, we take two variables here. One is called price, another one is called quantity. So for the certain sets of commodities, we take the prices of these commodities, we take the quantity of these commodities. So basically, whenever we have a base year, and the prices for the base year we write as P naught, and the quantity for the base year we'll write as Q naught. So this is the price of the base year. This is your price of the base year. We write as a P naught, and the quantity of the base year we'll write as Q naught. Okay. So we actually, when we talk about index number, we are talking about comparison of certain set of variables over the two time period. One is the base year and another one is current year. Okay, so the reason comes why we need to do this. What is the point of comparing the set of quantities over the two time period? The purpose of doing this calculation is to measure the inflation. Okay, is to measure like ultimately that how much the, if I'm talking about a WPI data or CPI data, we want to know how much our purchasing power ability has actually impacted because the expenditure on different commodities has changed over the year. Okay, the same logic can be even used in stock market also. So the same logic of index number we use in stock market. When you see Nifty, any index you talk about, Nasdaq, Dow Jones, FTSE, any index you talk about, they also use the same concept. It doesn't mean that this is only used on manufacturing products. So when we talk current year, we have the price. So the price of the current year. So you have a price of the current year which we write as P1, and then you have the quantity of the current year. This you write as Q1. Okay, so imagine if you have more than different set of variables like this, different sets. Okay, so you can write P1, P2 like that. Okay, so that you can easily understand by getting the question. So the quantity of the current year is basically, when we talk about the quantity of the current year, I'm writing as Q1. Okay, current year I'm writing as Q1. So here the expenditure of the base year you will write, suppose E naught means P naught into Q naught. That would be the expenditure. You know the formula, price into quantity is equal to expenditure. Everyone I think knows this formula. Price into quantity is equal to expenditure. So the expenditure of the current year, this is the expenditure of the current year. This I'll write as E naught or P naught Q naught, and the expenditure of the current year, base year, we write as P naught Q naught, and the expenditure of the current year, and the expenditure of the current year, and the expenditure of the current year I'll write as P1 Q1. Clear, everyone? So I think you can easily understand these are very self-explanatory things. Okay, so when we talk about index number, in the case of index number, we are considering different forms of index number. So when we talk about index number, we have different types of index number. We have price index number, we have price index number. Okay, then we have quantity index number, we have price index number, then we have quantity index number, we have price index number, then we have quantity index number, and then we have value index number, then we have value index number. So when we talk about price index number. Generally, if nothing is given as such mentioned in the problem, okay, you get certain set of data and they expect you to do some kind of calculation, then always understand that knowingly or unknowingly, by default we use always price index number only. Okay, so that part you should be very clear with. Value index number, there's only one formula for value index number: sum of p1 q1 divided by sum of p naught q naught into 100. This is a formula of value index. Okay, so remember this. Price and quantity I'll discuss later on. Basically, index number are of two or are of three types: price index number, quantity index number, and value index number. Okay, everyone. Any doubt, anyone? So with relevance of price, when I'm analyzing the index number, we use price index while keeping a reference of quantity. When I'll talk about an index number, then I'll talk about quantity index number. And when I use price and quantity together, where I'm comparing the present year expenditure with the base year expenditure, okay, then it is called as value index number. Fine, everyone. I hope everyone is understanding this part. Nobody have any doubt. By default, always whenever I talk about formulas also, no, of index number and all, you can understand by default, we'll always use a formula of price index number only. Okay, so last class we discussed about different methods under these index number. Okay, so when we talk about index number calculation, when we talk about index number calculation in index number calculation, when we talk about here, we talk about unweighted. Here we talk about unweighted. Okay, and then we talked about weighted index number. We talked about unweighted, and we talk about weighted. Okay, so when we talk about index number, they can be unweighted or they can be unweighted. Unweighted index number uh, can be either simple aggregate. They'll follow the formula under simple aggregate. They'll follow the formula under simple aggregate. Unweighted, they'll follow the formulas of simple aggregate or simple average of price relative or simple average. Unweighted index number, they can be simple aggregate or simple average of price relative or simple average of relatives. Okay, so the relatives can be price relative, it can be quantity relative. So index number, they can be unweighted, it can be simple aggregate or it can be simple average of relatives. Okay, when we talk about weighted, so weighted, when I talk about weighted, it can be weighted aggregate method, it can be weighted aggregate, it can be weighted aggregate method, it can either be weighted aggregate method or either it can be weighted average of relative method or it can be weighted or it can be average of relative method, weighted average of relative method. Clear, everyone? So basically, when we talk about index number, so index number, under index number, it would be unweighted index number. When we are studying index number, it can be unweighted or it can be weighted. Okay, so unweighted can be either simple price aggregate method, it can be either price aggregate, simple aggregate method, or it can be simple average of relative method. Okay, so when it comes to price, we'll say simple price aggregate method, simple average of price relative. Okay, and weighted, it would be weighted aggregate method, or it can be weighted average of price relative method. So this thing you need to understand one by one. I'll talk about both price index number. I'll talk about quantity index number, but you need to understand that in exam and all, when nothing is given, we always follow price index number only. Clear? Anyone, any doubt? Okay, so now I'll focus on price index number. Because 80-90% of time when we are doing this chapter, index number will only focus on price index number only. Okay. So will not deviate to other topics, will not go more into quantity. Till that time it is not given in the problem, we'll always calculate on price only. Okay. Okay, everyone. So here when we say simple aggregate method, so here if I say simple price aggregate method, here now I'm talking about price index number only. I'm talking about price index number. When I talk about, okay, if I talk about unweighted, okay, if I talk about simple price aggregate method, if I'm talking about simple price aggregate method, if I talk about simple, if I talk about simple price aggregate method, a simple aggregate method, because I'm talking about price index numbers, so no need to write simple price aggregate method. Simple aggregate method, the formula is sum of P1 by sum of P naught into 100. So if I follow simple, if I follow simple aggregate method, then the formula is sum of P1 by sum of P naught into 100. Okay. Then if I follow price relative method, so price index number of two type, unweighted and weighted. Unweighted are simple aggregate method. Okay, so simple aggregate method problems we discussed last class. Simple and so simple aggregate method problem we discussed last class. 1 minute. So we discussed right this question. Simple calculate the price index number of following data by simple aggregate method. So we follow the formula sum of P1 by sum of P naught into 100. Okay, this is simple aggregate method, and this will tell us the inflation rate, how much the prices of goods and services has actually increased in 2012 as compared to 2010. So this was simple aggregate method. Okay, so similarly, we have discussed about simple average. We have discussed about simple average method. We have discussed about well, this one is simple aggregate method. Other one is simple average of relative method. So if we talk about simple average of relative method, if I talk about simple average of relative method, if I use simple average of relative method. If I do by arithmetic mean, by arithmetic mean, if I do this by arithmetic mean, the simple average of price relative, if I do by arithmetic mean, then the formula of index number will be sum of P by N. And the formula of index number will be sum of P by N, where P is called price relative, it is P1 by P naught into 100. So we have discussed this here. P is called price relative. Here your P is called price relative. Here this is called price relative. Okay, here P is called price relative. Okay, and P value you will get by P1 by P naught into 100. So simple average of price relative, you can follow either arithmetic mean or you can do it by through geometric mean. You can do it through arithmetic mean or you can do through geometric mean. If I follow geometric mean, then the formula for that is NT log of sum of log P by N. So this is the formula. So this is the formula of simple average of price relative, simple average of relative method. Okay, so if we are following price index number, these are your formula. If you follow quantity index number, then your formula would have been simple average of price relative. Your formula would have been sum of Q1 by sum of Q naught, sum of Q1 by sum of Q naught into 100. Simple. And here the simple average of relative method. by arithmetic mean, this would be sum of q by n, where q is equal to q1 by q naught into 100. Like the way we discuss price index number, like the same way we can discuss quantity index number, right? Also, so simple average of price relative method, there are two things will be there, either arithmetic mean or either do geometric mean. So if you follow geometric mean, then your formula will be NT log of sum of log q by n, where q is equal to q1 by q naught into 100. You're getting it right, where q is a quantity relative, and that value you'll get by q1 by q naught into 100. Anyone, any doubt, any question? So now we'll discuss the simple average of relative method by geometric mean method. Yesterday we discussed till arithmetic mean. Okay, so now we'll talk about geometric mean. The same data only we'll use the same question. Question number two. Okay, question number two. The price index and unweighted aggregate method. The question number three. Okay, by using arithmetic mean and geometric mean, you can see the 2 years are given, 2010 and 2015. 6 years of profit is given to you. So you need to follow the index number by using arithmetic mean and by using geometric mean. So by using them, I need to find the index number value by following the formula price relative using arithmetic mean. Similarly, I have to follow price relative using geometric mean. If a price relative through arithmetic mean already I found last class with the formula I'll sum of p by n. Now I'll work on price index number on geometric mean. Price index number method on geometric mean, that I'll try to do today class. Okay, everyone. Let me first write down the question. So last class we did till index number. Today, so we have done till last class index number calculation by following price relative using arithmetic mean. Today we will start first with index calculation by using price relative method of geometric mean. Okay, so data is given to year. The data is given to us year. Then year are 2010. You have 2010, and then you have 2015. Price okay, these are commodities, not year. Commodity A B C D E F. A 45, 55. B 60, 70. 55, 2010, 55, 45. Then 70, 60. Then 30, 20. Then 75, 50. Then 90, 85. Then 130, 120. Clear, everyone? So if you follow the index number calculation of simple average mean method, so simple price relative mechanism by you working on geometric mean. So here what we need to do, you need to first find the P. You just need to find first P. Okay, 5 and 10, 2005. Okay, 2005, 2010. Find the P. P is equal to P1 by P naught. P is equal to P is equal to P1 by P naught into 100. This will be your P1. This will be your P naught. This will be 55 by 45 into 100. Then this will be 70 by 60 into 100. This will be 30 by 20 into 100. This will be 75 by 50 into 100. This is 90 by 85 into 100. This is 130 by 120 into 100. 11 by 9. 1, 2 by 9. 1, 2 by 9. 1, 2 by 9. 1.2. 122.22. 122. 122.22. 7 by 6. 1 by 6. 116.67. Then 30 by 20. 150. Then this is 3 by 2. 150. Then 890 by 85. This is 18 by 1700. 1 by 1700. This was 1 by 17 is how much? 5.8823. 1.05. 1.058823. So this this is this is 1 by 12 into 100. 1 by 12 is 8.33, right? 1.0833. This is 1.0833, and this is 1 by 17. 1.058823. 1105. 8823. Clear, everyone? So if you follow price relative by geometric mean method, or if you follow price relative by arithmetic mean method, in both the case you need to find the price relatives. Clear, everyone? Once you find the price relative, your work is still not done. Once you find the price relative, your work is not done. Your work is not done. Once you find the price relative, once you find the price relative by using the formula P1 by P naught into 100, P1 by P naught into 100. Once you get the P, then find the log P. Find the log P. So log of 122.22. So use the log. So if you see here log, characteristic of log will be 3 minus 1, 2 point something. This will be 2 point something. Okay, this will be 3 digits are there. No? Log of 116.67, that will be 2 point something, 3 digit 2 point something, 3 digit 2 point something, 105.88, 2 point something. Then this will be 108.33. This is 2 digit 2 point something. You are getting it right. So this is called characteristic. Count the number of digits. Count the number of digits before decimal, and whatever the number of digits you get minus 1, that will give you the characteristic. So count the number of digits before the decimal, and characteristic will be that many number of digits minus 1. That will be your characteristic. Then how to find the Mentisa? The decimal part is called Mentisa, and the what you say integral part is called characteristic. So 2 point. So then what you do? Go to the log table. Go to the log table. In the log table, in the log table, in the log table, if you see the first one, 122.22, see the column 12 and row 2. Column 12 and row 2, that is 0.0864. 0.0864. So this is column 12 and row 2. You will get 12 at 2, no? That is 0.0864. 0.0864, and then mean difference is the mean difference. So 0.0864 and then 7, 0.0871, 0.0871, 0.0871, 0.0871. This will be restricted. Second one, 2 points, see 11 ka 6, and then you can see 7. 11 ka 6, you can do round of 11 ka 6. 1, 2, 3, 4, 5, 6. Point 0, 11 ka 6, 0.0607. 11 ka 6. 1, 2, 3, 4, 5, 6, 0.0607. 7th and 26, 0.06, 0.06, 11 ka 6, 0.0607, 0.0607, and then 11 ka 6, 19. This is 0.0626, 2.06, 11 का 6 then 6. 1 2 3 4 5 6. 1 2 3 4 5 6. 0.0607. One minute. 11 का 6 and then 6 or 7. 11 का 6. 1 2 3 4 5 6.0607. 0.0601. So this is 0.0626. Okay, then 152.15 का 0. 15 का 0 is 761. 1761. Okay, learn how to use log table, how to see the, then again 2.1761. Then 5 cut 10, 8, 8. 5 cut 10, then 9. You can see 5 cut 10, 1, 2, 3, 4, 5, 6. 0.0212, 0.0212, and then 8. Then 8, then 8, then 8, 8 is 33. 0.0245. Then 8 cut 10, then 3. 8 cut 10, then 3.0334. 8 cut 10, 0.0334. Then 3, 12. 0.346. Then 8 cut 10, 0.0346. Clear everyone? Find this value. Learn how to use log table in case if you don't know. Find this value, sum of log p. The sum of log p, do that. You will get around 12.5653. Close to this. Do the sum of this. Any doubt, anyone? And then if you follow simple average by price relative geometric mean method, simple average by price relative method. So geometric mean, if you calculate, so the anti-log of sum of log p by n. So you can write this anti-log of sum of log p 12.5653 by n. N is how much? N is how much? 6. Clear anyone? Anyone, any doubt? Divide this 2.07088 something in get 12.5653. If I divide by 6, let me just check with calculator. 12.5653 if I divide by 6, I get 2.09. Okay. 2 point, okay, 09. 2.09421, something like that. Okay, everyone. So what you do if you are using anti-log table, then this will be your characteristic too. For anti-log, whatever the characteristic, we'll count, we'll see the digits before the decimal and plus 1. That will give us the like after how many digits we need to put decimal. So this will tell us after 3 digit you have to put decimal. Why after 3 digit? Because you can see the characteristic here is 2 point something. Are you getting it? Anti-log is the reverse of log. So in log, after 3 digit decimal was there. Right. So what you do 3 minus 1 to find the characteristic of anti-log. Similarly, for anti-log, if you want to convert into log, so 2 point something is that. So the characteristic of anti-log would be after 3 digit 2 plus 1, you put decimal. Now what you do, just go an anti-log table, see for 09 column, see the row 4 and go to anti-log table, go to the anti-log table, in the anti-log table for 09 column, 09 column, okay, row 4. So that is 1242, 1242, and then mean difference to 1242 plus 1, 1243. So 1243, 1243, and after 3 digit decimal will come. So this is the value of the index number 124 point. Anyone, any doubt? Log, anti-log, anyone have any confusion, any doubt? How to work on log, how to work on anti-log? Anyone, any question you want to ask? You can Google, or if you want, I'll take a separate session for log, anti-log for you if you want. Clear?